All right, this is screencast number 2 for Unit 4, Lesson 3. I'm on page 204, and we're going to start talking about Newton's 3 laws of motion. We're going to start with the first law of motion. Okay, Newton's law of inertia, otherwise known as Newton's first law of motion, states that an object will not move or change its motion unless it's acted on by an unbalanced force. And it says at the heart of this law is the concept of inertia. Inertia is the tendency of an object to resist changes in its motion. Okay? Because of inertia, an object at rest will remain at rest unless an unbalanced force is applied. Okay? In addition, a moving object is going to stay moving with the same velocity or speed in a particular direction unless an unbalanced force changes its speed or direction. So unbalanced forces always change the motion of an object. We have talked about that. Unbalanced forces cause acceleration. Okay? Unbalanced forces always change the motion of an object because the net force on the object is not zero. All right, look at the first red subheading. This is basically, the two red subheadings are sort of breaking down the two parts of Newton's first law of motion. Okay? Remember, if you go back up to the top paragraph, it says that an object will not change its motion unless acted on by an unbalanced force. So, if an object is at rest, I'm out the red subheading down here. If an object is at rest, it's going to stay at rest unless it's acted on by an unbalanced force, unless it's made to move by an unbalanced force. Okay? An object in motion is going to stay in motion at constant velocity unless it's acted on by an unbalanced force. So again, in both cases, an object is going to keep doing what it's already doing unless it is forced to change by an unbalanced force. Okay? Okay. I will show you my little notes and highlighting in a minute, but go ahead and go to page 205. Why does friction affect motion? Okay. Friction is a force that opposes motion between objects that are touching. Friction exists between the surface, for instance, of a soccer ball and the grass on the field. The rougher the surface of an object, usually the greater the friction force. Okay. Friction often acts as the unbalanced force to slow objects down. And because of friction, an object rarely maintains constant motion. Okay? Y'all know that if you kick a ball, it's not going to roll forever. It eventually slows down and stops. And it's not because it violates the law of Newton's first law of motion. It's just because we have to keep in mind that friction is the unbalanced force that tends to slow down and stop that object. Okay? We would have to apply a constant force to counteract the force of friction if we wanted to keep going forever. Okay. All right, so let me show you what I've got on these 2 pages. All right, the first thing I want you to notice is up here, I put several synonyms for the word inertia. The amount of inertia is directly related to the amount of mass of an object, so more massive objects have more inertia. And you can kind of think of inertia as laziness or resistance. It's the resistance of an object to changes in its state of motion. Okay? Objects are going to tend to do what they're already doing unless they are forced to change what they're doing. Here, it's kind of squished into the margin, but I put more mass means more inertia. Okay? Here, I underlined where it said, where it said Newton's law of inertia, or Newton's first law of motion, states that an object will not move or change its motion unless acted on by an unbalanced force. Underlined the definition for inertia, the tendency of an object to resist changes in its state of motion. Underlined where it said unbalanced forces always change the motion of an object because the net force of the object is not zero. Then they broke down Newton's first law into basically 2 statements. An object at rest stays at rest, and then I completed it because I don't like the fact that they left you hanging. An object at rest stays at rest unless acted on by an unbalanced force. So I added that in purple. Down here, an object in motion stays in motion at constant velocity unless, and let me move this up, again, unless acted on by an unbalanced force. So, objects are going to keep doing what they're already doing unless they are forced to change because they are being subjected to an unbalanced force. Objects at rest will stay at rest unless acted on by an unbalanced force. Objects in motion will stay in motion at constant velocity unless acted on by an unbalanced force. All right, let's look at page 205. Okay, under the blue heading, why does friction affect motion? Friction is a force that opposes motion between objects that are touching. The rougher the surface of an object, the greater the force of friction. Friction often acts as the unbalanced force to slow objects down. And because of friction, an object rarely maintains constant motion. Okay? So, the answer to this question, why don't objects stay in motion? That's because friction is the unbalanced force that tends to slow the object down. Then I put down here, what determines the amount of friction? There's actually two things that determine the amount of friction. The type of surfaces that are in contact and how hard those two surfaces are pressed together, which has to do with the object's weight. Okay? So the rougher the surfaces, the more friction you're going to have. The heavier the object, the more friction you're going to have too. Okay. On page 206, how is the law of inertia applied to everyday situations? Okay, inertia is the property of matter that causes a moving object to keep moving and a stationary object to remain at rest. For example, try walking on a slippery surface. It's hard to keep your balance as your body moves even after you try to stop. As another example, when you first start to pedal a bike, you have to use a lot of force to overcome the inertia of your body and the bike. Okay, great example of applying the law of inertia is automobile safety devices are designed to protect people from the unwanted effects of inertia. Consider what happens when a car is in a crash. While the car suddenly stops because it's hit something, the people inside the car continue to move forward with the same speed that the car was moving originally. So this is why we use seat belts and airbags, because if you'll look in, for instance, in scenario 1, you have a crash test dummy with no seatbelt restraint, no airbag. So the crash test dummy is moving forward with the same velocity as the car. The car suddenly stops, and without a seatbelt, the test dummy continues moving forward, and it's going to be stopped by the windshield, the steering wheel, whatever. The person may be ejected in through the windshield, whatever. Okay? So we want to control the way that crash dummy stops, and so we're going to do that with vehicle restraints, seat belts, and airbags. Okay, the crash test dummy in scenario 2 is moving forward with the same velocity as the car, and if the car suddenly stops, the seat belt applies an unbalanced force that prevents the test dummy from moving forward. So it's the seatbelt is going to try to slow down the test dummy a little more gradually, obviously, than just hitting the steering wheel or hitting the windshield. Okay. Also, the airbag prevents the test dummy from moving forward and striking the steering wheel. Okay. All right. Just a reminder on page 207. That's a neat little interesting scenario to look at, but you do not need to do 12, 13, and 14.